All right, welcome. We're day 13 now, and we are looking at lesson 43 and 44 today. So, lesson 43, we're looking at equivalent division problems, finding unknown fractions, and decimal problems. So, working more with fractions and unknowns. So, equivalent division problems, this is just a rule that we can use to kind of manipulate or rename the problem in a way to make it that a lot easier. So, if I said 700 divided by 14 or 350 divided by 7, some may say the 700 divided by 14 is easier. I think most would say 350 divided by 7 because we're dividing by a single digit number, and we know 7 goes into 35 5 times, so it goes into 357 times. But they're actually the same because we divided 700 by 2 and 14 we divided by 2, just like when we're dividing, in fraction form, we're just simplifying the fraction, the same thing we're doing here. So we divide both the dividend and divisor by 2, and we get 350 divided by 7, which is a lot easier. If we have 7.5 divided by 1/2, what I would do to get rid of halves on both of these is I would multiply by 2. So we'd end up with 15 divided by 1. 15 divided by 1 is much easier because it's just 15 than doing 7.5 divided by 1/2. We can do that if we convert this to an improper fraction. We keep, change, flip, we multiply by the reciprocal, and we end up with 15. We're still going to get the same answer, it's just sometimes we can make these mental adjustments to our original problem and make it a lot easier. So if we're looking at this 1200 divided by 16, well, I'm thinking right away I want to divide by a single digit number. Okay, I don't want a fraction. I want 2 or 3 digit number. For me, dividing by a single digit number, 1, 2, 3, 4, 5, 6, 7, 8, 9 is going to be a lot easier. So if we divide both of these in half, again, we can't just do it to one and not the other. So divide in half, I get 600, and then I get 8 right here. So 600 divided by 8, and then we work through the problem, and we end up with 75. And we still would have got the same answer. It's just, if we can divide and manipulate the original problem to make it a little bit easier, especially if we're doing it mentally or by hand or something like that, it's going to make life a lot easier. Maybe we saw one like this, 7.5 divided by 2.5 earlier. So I would double this, make it 15, double this. 2.5 times 2 is 5. 15 divided by 5 is much, much easier than working with mixed numbers. 15 divided by 5 comes out to be 3. Right, then if we have unknowns, so we've worked a little bit with unknowns. So anytime we have X, Y, Z, A, B, C, whatever we're calling it, uppercase, lowercase, that doesn't really matter. We just have a placeholder for one of these values. We think inverse operations. So I have a number that I'm trying to find an unknown, minus 5 equals 3.2. So what we do is we come over right, so the inverse of subtraction is addition. So I add 5 because minus 5 plus 5 is just 0. So that's how I'm able to get rid of this on the left side. I have to do the same thing. I can add in a decimal if I want to. I have to do the same thing to the right side. So I get 8.2. Sorry, poor handwriting. So our unknown D equals 8.2, and then we could plug it back in. 8.2 minus 5 does equal 3.2, so we know we did it correctly. Okay. In this example, fractions, we would subtract. Okay. In this one, we're multiplying 3/5 times n equals 1. Well, in this case, we want to divide. Since we're multiplying, we want to divide. And dividing by a fraction is the same as multiplying by the reciprocal. So we are dividing by 3/5. But when we divide by 3/5, that's the same as multiplying by 5/3. So we have our equation. And yes, we are going to divide by 3/5, but 3/5 divided by 3/5 is the same as 3/5 times 5/3. So we multiply, we can think of it as division, or you can just know right away it's a fraction. So I'm going to multiply by the reciprocal. 3's would cancel out, the 5's would cancel out. So that's how we get rid of it or cancel it out. If I multiply the left side by 5/3, I have to do the same thing. Okay. So n equals 5/3. Again, we could plug that back in. 3/5 times 5/3 does equal 1. So we know we did it correctly. Okay. Practice set we will go over as a class when we return. Okay. And then the second lesson that we're going to cover in class is simplifying decimal numbers and comparing decimal numbers. Okay, so when we add or subtract, we want to make sure that all of our place values line up. If we have a decimal number, what's nice about that is we just line up the decimal and automatically all the other place values are going to line up. So we're looking here. If we have 425 minus 125, we get 3. If we get 4.25 minus 1.25, we get 3, just 0.00. So that decimal lines up, and it's essentially the same exact mechanics of subtracting a 3-digit number as it is this 3-digit number, even though we have the decimal. As long as the decimal is lined up, it's the same process. Okay, multiplying a decimal. So what I always think of is don't worry about the decimal when we're multiplying until the very end. We'll talk about when dividing by a decimal because we want to divide by a whole number. There's a way we can manipulate that equation to make it work. But I would just do, okay, the decimal we will account for, but let's do it at the end. So just 25 times 4. Oh, well, 25 times 4, 25, 50, 75, 100. It's 100. And then I have 1, 2, 3, 4 decimal places. So 100 would be right here. And then I move it back 1, 2, 3, 4 decimal places because I had 1, 2, 3, 4 right there. And there's my answer. So when we're multiplying using decimals, just think of it as any number, multiply it just like you would. And then at the very end, whether you had 1, 2, 3, 4, however many decimal places, just slide it that many places to the left. And there's your answer. Okay, when we're comparing decimals, okay, we can write 0.3 as 0.3 or 0.30, 0.300, okay, zeros into infinity if we wanted to. And sometimes that just helps when we're comparing. So if we have again, compare means these two numbers are either going to be equal, the one on the left is going to be greater than the one on the right, or less than the one on the right. So these are symbols that we're working with. So we're comparing these. Well, if we make this 0.300, now we can compare it a little bit more easily because they look very close and they are. Okay, the 10th place, they're both 3s. That doesn't help us. The 100th place are both 0s. That doesn't help us. The 1000th place, 0 and 3. Well, 3 is greater than 0. So this one is greater than this one. And so if we take it out to the equal number of decimal places, and we just keep working left to right until one of those numbers is bigger than the other, and that tells us it's greater. It doesn't matter what comes after this or after this, if it was 8, 9, or whatever. Okay, we just start at the highest place value. In this case, it was a decimal, and then work to the right until we have one that is greater than the other. Okay, so we ended up with that. Can do the same thing here, comparing from least to greatest. So if we took them all out 3 digits, well, we look at the first, the ones place, they're all zeros. So that doesn't help us. The tens place, 3, 0, 2, and 2. So this one's greater. This one's the smallest. And then these two, we need to figure out which one is greater. 4 and then 3 in the hundredths place. So 4 is greater than 3. So 0.3, 0.24, 0.235, then 0.042 would be the order of, if we were going greatest to least, in this case, least to greatest. So yeah, 0.3 would be the largest, 0.24, 0.235. And then there's your practice set. We'll do that together as a class. So just come to class with homework done and ready to go. See you guys then.